Hi, my name is Kylie, and my project offers a unique perspective on landscape architecture's role in space. We're going to jump into the future of space travel and discuss how landscape can provide the solutions to the setbacks faced. With Mars colonization closer than ever, the world has been working to create innovative solutions to interplanetary problems. We have refined our technology to near perfection, however, the greatest threat to our endeavors lies in our own faults and limitations. Research shows that human error is the greatest threat to the success of space missions due to mental fatigue associated with stressful environments. Landscape architecture offers a unique solution to this setback through applications of attention restoration theory. This theory provides framework to create therapeutic environments through the use of specialized landscape. By providing restorative gardens for astronaut well-being, landscape architecture will enhance the mental health and restore focus to crew members during critical space missions. Based off Rachel and Stephen Kaplan's attention restoration theory, my goals and objectives will focus on enhancing the Martian experience. This project will provide clean air while enhancing and restoring mental well-being. In addition, the space landscape brings opportunity to facilitate diversity and cultural inclusion, as well as redefine how we visualize Mars. My proposed project site is the red planet of Mars. As of today, the current population is 0. However, there are 43,000 impact craters. Additionally, the planet has 2 moons orbiting and 687 days per year. Utopia Planitia is the largest known impact basin in the solar system. Famous for being the landing location of Viking 2, this region features a periglacial landscape carved from ancient ice and winds. Since water is a key factor to any civilization, the ice deposits located here will serve as a vital resource to the Martian colony. With a landscape so rich in history and resource, this crater basin would make a great location for a civilization. The universe is littered with galaxies of all shapes and sizes. Nothing but clusters of stars, dust, and gas. We live in one of the largest galaxies known to man, the Milky Way. The closest neighboring galaxy to us is the Andromeda Galaxy, approximately 2.5 million light-years away. While distant galaxies are not yet reachable in our lifetime, some will drift closer to us in time. Our solar system is one of myriads. However, our placement in it is not. Earth and Mars both exist at a zone that is capable of sustaining water at liquid form. Without this unique zone, our lives would not be scientifically possible. Earth, where it all started. Our beloved home is currently host to many different research objects, satellites, and telescopes. The ISS, perhaps the most famous orbital apparatus, has been floating in the gravitational field for 20 years now. The ISS resides in the exosphere at the top of Earth's atmosphere, approximately 250 miles above the ground. Drifting through the sky at 17,500 miles per hour, the craft serves as home for astronauts while simultaneously functioning as a laboratory for their various experiments. The space race started in 1957 when Soviet Union launched the first satellite, Sputnik 1. What originally began as rivalry between two nations, human space exploration is now a symbol of camaraderie and achievement. On the ISS, countries from all across the globe come together with a common goal of advancing science and understanding. The space station has welcomed over 1,000 visitors, hosting cosmonauts from 18 different countries as we study and prepare for further exploration. With space exploration being a relatively new topic for science, we are still in Phase 0, conducting countless studies and tests in an uncertain environment. Phase 1 starts with colonization of our moon to function as a lunar base for future space travel. As research progresses, we will see further advancements in technology. We will begin to set foot into new worlds. NASA has laid out a 4-phase exploration plan, ending with the colonization of Mars. SpaceX was founded by Tesla tycoon Elon Musk in 2002 with the hopes of discovering cheaper means of space travel. The American company specializes in aerospace manufacturing as well as space transportation services, such as launch vehicles and spacecrafts. The main focus of SpaceX is to colonize Mars within our lifetime, to create a civilization that represents the peak of science and mankind's achievement. As of now, there is a wide variety of resources for landscape architects on Mars. With humanity's rich knowledge of Martian geography, we have developed accurate models and maps of topographic features, mapped wind patterns, and even created AutoCAD elevation models for the red landscape. In 2018, 11 magazine announced Marstopia, an architectural design competition for the first colony on Mars. The purpose of this contest was to define Martian vernacular architecture and ignite debate of Martian colonization within creative fields. For this project, the competition highlights an incredible opportunity for humans to build a truly utopian society. Designing a society based on science and human experience can revolutionize the way we view landscape. The Biosphere 2 is an artificial ecological simulation owned by the University of Arizona. The 3.1-acre facility remains the largest enclosed ecosystem ever to be constructed. Boasting 7 different biomes, the project sought to showcase enclosed ecological systems as a viable infrastructure for space colonization. Interactions between humans and the various biomes were studied and recorded in order to see how technology and farming practices can affect an enclosed ecology. The experiment provided scientists with a rich palette of resources and studies to further expand our capabilities within space. In response to air quality concerns on the ISS, NASA partnered with the ALCA to discover if plants could clean and purify indoor air. The study identified and analyzed a handful of indoor plant species that can be used to improve air quality in small spaces. Plants were tested for filtration of air pollutants such as benzene, formaldehyde, and ammonia. Results have been recorded and charted for future use on space missions. The Advanced Plant Habitat System curates plant growth in space through manipulation of light, humidity, temperature, and carbon dioxide levels. Plant growth is mostly autonomous, regulated through a specialized computer system that will adjust to different types of plants. Since the introduction of this growth chamber, scientists on the ISS have been conducting lots of experiments on how plants behave in low-gravity environments. Justin Benjamin's piece highlights the growing need for landscape architecture in space. In this paper, the author brings forth research from a study conducted by NASA that determined human error to be the weakest link in space exploration. Because human error results from mental fatigue, the space program can benefit from mental restoration gardens that will augment the health and well-being of crew members. Attention restoration theory bloomed from the research book The Experience of Nature, A Psychological Perspective, which explores the relationship between humans and the environment. First, the authors performed countless research studies and experiments as documented in the first half. Then the information was compiled into guidelines and framework for creation of therapeutic landscapes that have the power to restore mental energies. This last theory is about designing for diversity and how landscapes should address a hierarchy of needs for users of all cultural backgrounds. Diversity will be important in design decisions because astronauts and colonizers will come from all over the world. My thesis contends that landscape architecture can enhance the human experience of space travel and colonization by providing habitable environments for human well-being. Through various techniques and applications, such as attention restoration theory, landscape architects can build therapeutic gardens that will set the pace for a higher standard of living on Mars. The current setbacks of humans in space require modern solutions, and I believe landscape architecture can prove essential to interplanetary success. There are a lot of resources for landscape architects to use on the internet in regards to both space travel and interplanetary colonization. As far as the immediate timeline looks, we're still in the beginning stages of testing and refining our technology. However, it is predicted that the 2020s will focus on a lunar base and the 2030s will bring a space travel ending in humans on Mars. This timeline shows that we will likely see Mars colonization within the next few decades. With humans already in space, I feel that the time is now for landscape architects to jump in. Well, that just about wraps it up. Once again, I'm Kylie Deans, and this has been a presentation of my research for my upcoming 2021 senior project. Thanks for listening.